Hello everyone, good afternoon. My name is Hussah Aldawish. I'm from King Fahd University of Petroleum and Mineral, Saudi Arabia. It doesn't work. Maybe I'll try it here.
It works. It works, right? Hello? It did work.
Yeah, I clicked here.
Okay, is this one?
Maybe I'll try clicking here. No, this one, right? It's okay, I can just
We need
click.
that. We need that. We need that. No, it should. Normally it should work with that.
I'm representing the first generation of female aerospace engineers in Saudi Arabia. I know, it's 2025, but we're getting there. My work is, firstly, I'm a junior aerospace engineering student, my third year. My advisor is Dr. Bahram from the IRC of Aviation and Space Exploration. Today I'll be talking about communication to Mars. First, with the early generations, I know we have established the necessity and the need to explore Mars and everything, but one important aspect is communicating this data back, learning what we have gathered. So we started in 1997 with the Sojourner rover. I hope I pronounced it right. It used UHF telemetry link only, and it was very moderate, or let's say low data rate, basic telemetry, not for high resolution science search data, but we managed. Then in the X-band era, my birthday, 2004, we started using multiple antennas, different configuration. We used the microstrip patch, we used horn antennas, we used monopole. So this configuration helped us gather more and much higher downlink rates than earlier missions. And now with the advancements, the modern systems like Curiosity and also present Rovers, they're using and combining multiple antennas in X-band and also UHF bands. But I'm presenting different one, which is Ka-Band. Ka-Band for high telemetry data rate, because as you know, UHF is too low, and for heavy missions, we have developed good instruments. We have gathered very rich scientific data, so we must consider giving more to communication systems. The communication system I'm proposing is for compact rovers. It doesn't have to be compact rovers, but preferably compact. Of course, you know we have many constraints. One of them is the weight constraint and also the power constraint. You can't supply electricity live to the rover. So you have to factor in the weight of the antenna, the weight of your communication system. If we used compact antennas, if we used much lighter antennas, it would be better. But of course, you can say, why not use let's say heavier antennas just for drag and stabilizing the rover. But it depends on the rover design. So we started with a single microstrip patch antenna, developed on Rogers RT 5880. You can see how compact and lightweight it is. It's only 9 millimeter. You can see here the results, the S11 results. The antenna is fabricated and measured, only measured at 26.5. It's designed and simulated on CST, French software. Also, we scaled up the array to 1x2 microstrip patch array. You can see here the difference in the bandwidth. We have much larger bandwidth in the S11 results. And now you can see the radiation pattern or the gain results between the single patch and the array. You can see here the difference and the improvement in the gain, almost 3 dB. But now to the 2x2 microstrip patch array, of course, as you know, when you scale up the array, you get more gain, of course. You can see here the bandwidth. It's wideband and operates on multiple. Here, not so much, but you can see here it operates from less than 26, around 28, with good VSWR. So we can say it operates sufficiently between 26 to 28. And you can see, of course, the improvement in the bandwidth. And the gain. The gain is around 13.1, but I have improved the impedance, and we reached around 24, which is not usual for microstrip patch antennas, as only horn antennas do. So here we see the link budget analysis. For 300 kilometers, we have reached 546 megabits per second, which is very good for our case. We're only using 2x2, not the improved version of it. But of course, with the much larger distance, as you know, the free space path loss, much larger distance, we lose the signal. But we can still operate, and very excellent operation. We can have live videos and HD videos and images, of course. Now for the KVPM antenna. I had this crazy idea of just fabricating and measuring and designing an antenna that has some symbolic or aesthetic reasons. Actually, I wanted funding from KVPM. I didn't get any. So I designed, this is the KVPM tower. It has many slotting, and actually it has scientific reasons. When you slot the antenna, you miniaturize it. You have it more compact. You can operate in different bands, but I'll come to that later. But due to some reasons, I have fabricated the antenna on FR4, a different substrate than the one I'm using for space. Of course, FR4 can't be used. But we have simulated this one on Rovers, and it gave us very good data and very good gain analysis. So you can see here the S11 from the frequency range. Because of the slotting, it operates on different bands, mainly X band. This one is for FR4. X band here. You can see here the difference between the measurement and the simulation. The measurement gave us better data than the simulation, better results than the simulation. It operates on the 6G, Saudi 6G, and X band for space communication. We can use this one for orbital relay, and also we can use the 2x2, the improved version for direct to Earth communication. But this one can be also used for rover-to-rover communication as we improve and have different rovers on Mars. So second thing I like about space exploration is the versatility, not only in the market growth, if you're looking at it from an entrepreneurial side, but also the adaptability to different applications. This antenna is very compact. This antenna is very light. It can be used in different and multiple applications. One of them is fighter jets. No one likes it, but it can be used to fighter jets. It can be used on rockets. If you use different substrate, like the Rogers laminate, and you name it. So for the future work, of course, we have to enhance and optimize the design, scale it up to 4x4, and fabricate and measure, surely, then integrate to different applications. Thank you, everyone.
Very good. So we save some time. So some questions?
Yes, please.
Have you made some tests?
Yeah, I did it on only the KVPM one because I couldn't get the Rogers substrate. You know, I can't order it myself. I have to be with some institution. Yes, please.
Yeah, so just going back to your figures with the charts. So you talk about a couple of the big table where you showed all the, yeah.
The link
Here.
budget?
Okay, so you're saying you have a 5-watt radio and you're able to transmit all this data What were the distances that you're talking about?
300 kilometers and 800 and 1500. I'm only presuming this.
So with 5 watts, you're transmitting 500 megabits a second, 300 kilometers. So have you tested this on Earth?
I mean, I would love to test it. I haven't fabricated anything, it's only simulation. I would love to do it, but of course I can't do it myself. I can't order just Rogers or fabricate my antenna myself.
Okay, would this frequency work on Earth, or would there be atmospheric absorption because of water vapor?
Of course, because Ka-Band ranges from 26 to 40 gigahertz. It's very sensitive to atmospheric attenuation, but it should work because they've been using Ku-bands and Ka-bands for drones in Japan. And I have seen many applications on using Ka-band, especially in military jets.
Thank you.
Thank you.
Apart from the military fighters, what can be the other use cases?
As I said, it can be used for the Saudi 6G, and of course, any telecommunication. It's just an antenna. It can be scaled to any application you want. Exactly. But this one has very high gain and low wavelength, so it's a compromise. Sometimes when you have high gain, you have bigger antennas, like the horn. It's very bulky, the one they're using now. But this one gave us good results just because we scaled it up.
Okay.
Thank you.
Do you foresee, maybe it's completely wrong, do you foresee any impact from the thermal side? If we're on Mars, we'll probably have a high range of
Yeah.
temperature we have to...
Exactly. That's why we're using Rogers.
Okay.
This material have been tested before.
So no specific impact, but okay.
I have one question.
Yes, please.
Okay, if there is a hill between with the rover and there's a hill and you want to reach the satellite, for instance, so what would be the
We use beam steering.
yeah?
The beam is steered, and do you get it?
No.
You steer the beam. So let's say I'm pointing at you,
Yeah.
and now you're the hell, but I can then just steer the beam. It can be steered.
Okay. Yeah. Okay.
Automatically,
I
so-
understand. But if there is a hill, so you lose the signal, or you're
No, you just steer it different way. You mean
yeah. But the satellite is not in the view, so
Yeah, he's asking if the line of sight needs to be clear.
yeah.
for it to
I
work.
guess
no.
No?
You can
Can-
communicate through it.
it can go through.
Yeah.
So maybe the question could be
You can go through if you have refraction. Only refraction. And you lose a bit of the signal even more.
so maybe it's more complex.
But you can still have communication if you have a hill between your antenna and the satellite.
The hell is between the antenna.
Yeah.
You can do that.
Maybe a small rock in between, perhaps, but if it is a hill.
So the hell is where exactly? Sorry, I don't understand. Where's the hell?
Sorry.
The hell, where is it? Is it?
I don't know. I mean, you have a rover, then you have
You
the
mean
antenna.
you're asking if we can penetrate through the hell?
Yeah, this is the question. Of course not. Yeah.
I would say that with that kind of rates, it's such an improvement from what we have that with a different passes, you don't need continuous line of sight to transmit all the data you need. I mean, of course, if you want direct communication for real time, you'll have to have relays and stuff, but it's compared to what we have now, it's pretty good rates. So I don't think you would need permanent line of sight,
Okay.
at least not to download such things as videos.
Thank you. So last remark. Yes.
As far as you know, is that a unique design, or is there anything else in the world that's similar, or is this what you're
You mean
proposing?
microstrip patch? No, it has been used before, but only low gain.
Oh, I see.
Yeah, deployed on Curiosity, I think, but very low gain. But here, the thing is, we have better gain than the previous ones, but it's still compact.
Okay. Thank you very much.
Thank you.